maximize the utilization of the limited page frame, the memory size, why don't we share some of the code, what? Some of the program. For example, what? You are using a lot of shared library, shared object. Do you compile all the instruction and all of your program? No. Mostly you are using existing library, okay? And then you can focus on your own logic, your program code. Okay. What about such a shared library? What about such a existing object? Somebody may use same code, same library. So instead of allocating the page for each process, the shared code, shared library can be located in the memory and pages, then they can be accessible by other process. Okay? For example, in this case, the ED123. For example, when you execute the Microsoft Word, only one, for example, this one, the PPT, I can open the chapter 3, chapter 4, chapter 5 at that time. Does operating system copy entire PowerPoint.exe file to the memory? Most of them are same, right? Only my file, chapter 3, chapter 4, chapter 5 are different. So it's the same thing. ED1, ED2, ED3, ED1, ED2, ED3, they are the exactly same code. So instead of loading the entire process, why don't we, if there exists ED1, ED2, ED3 in the memory, physical memory, we can share such a the command program, okay, that is a shared page. Then we can load only the data only. Then we can focus on the more about the structure of the page table. As I said many times, most of the algorithm, most of the things that we discuss in this class, computer science, the subject, is related to the structure. How are they organized in terms of 0 or 1? Okay, so it's the same thing. Page table data structure. Sometimes it can be viewed as algorithm. Sometimes it can be viewed as a physical data structure or logical data structure. So anyway, when we have the bigger size of the memory, that means we have many, huge number of pages. It's hard. It's also the problem. So there are different ways to organize such a number of pages. First one is a hierarchical paging. You can guess what is a hierarchical page. Kind of priority. Hierarchy means it's 3, top to bottom. So you can imagine index, multi-level index. Okay, instead of the linear sequence of pages, you can organize some of the pages, then up, like that. Okay, hash probably utilize hash function to find the specific hash page, the pages frame. Inverted page. What is an inverted mean? Have you ever heard about the inverted index? I believe you every day you are using the inverted index. What is that? No? Yes? Inverted index. What is an inverted index? It's an inverted.
Doing something opposite.
Opposite. Reverse way. What is the non-inverted index? It's opposite of the inverted index. So what is the nice example of the inverted index? I think that you are every day. What you are using every day? So I can live without television. I can live without the food, but I cannot live without Google. Can you survive without Google? If I need to select one of them, probably I will select the Google. How can I survive? I can search. So Google use what? The main part of the Google is the search engine. Have you ever think about how search engine is working? They have bunch of HTML5 data. Okay, it's HTML5 document. But how do you search?
It's too much.
It's a keyword, right? So I try to search Jeongyu Lee or the computer science and project B. How can I solve the project B? Like that, or PFS. Not much you can return from the PFS Google search. You already did, right? So I did. So keyword. So how many web pages does Google have? Millions, billions. Google. That's the reason the name is Google, right? Google is something huge amount, certain level of number, whatever. So it doesn't make sense. Whenever you search the, for example, portable file system, the Google go through all the web pages? No, definitely not. Then at that time we need index. Okay? Then index is the data structure to speed up for searching. That index, for example, Google already go through which page has Jeongyu Lee and the first page HTML and second page HTML, okay, and 10, something like that. So if somebody search Jeongyu Lee as a keyword, then return. Instead of going through entire page, return this one. Most of the naive way of index is 1.html file and try to organize this data itself, right? That is general way of indexing. But inverted index is the opposite way, using data item. Not sure whether data item is correct word. Anyway, it's element of this one, right? Target data. Our target data is the HTML file. But using word, we can organize. So this 1.html file will be happen like the University of Bridgeport keyword. Again. Right? Most of data item will be managed just one time in most of the index. It's a naive way, but inverted index is like that. So that is inverted index. One good example of such an inverted index is man and woman. It's a cardinality. It's a half and half. So it doesn't make sense if you organize them. If you make the index, the column, the sex by the B plus 3, B3, how many different data? Only two, man and woman. Okay? So it doesn't make sense to make the index. However, opposite way, man is in the Lee and the James, whatever, Scott, and the list of the woman. This is the inverted. So, inverted index table utilize such a way. We will see details of it. Hierarchical page is a page table of other higher level of the page table we can access. Just like the multi-level index, it's exactly the same idea to find the data. So 2 level. What if we have bigger size of the physical memory of the 3 levels? We can make the 3 levels of the page table scheme. In the 2 level page scheme, we need to allocate the address format. Right? This is a page offset. So we need to, if we are using the, in this case, it's a 2 to the power of 10, 1K size of the page. Then this is the first level, this is the second level. And the first level and second level. Okay. So this is the address translation scheme. So first from the P1, so we can get the address of the our page table, top level page table. Using that one, we can find the address of the second, actually page number. Okay. So page number of the page table, and finally, it's the pages. In case of 64-bit, the processing, 64-bit processing architecture allows 64-bit address format, the bigger size of the outer the page table, which means we can manage the bigger size of the memory. That is the reason 32-bit processor allow bigger size of the memory or file system than 16-4-bit. Why? Because it allows longer the address format. So you can that limit the size of the files and size of the memory. Even you can implement the second outer page, inner page. Top level, middle level, then lower level, and offset. Hash. Anyway, our goal is to map the logical memory program page to the physical memory. Okay. Then, what is a hash? What is a hash? Hash is the function, okay, that provide what? Hash function can make very long size or complicated data small or short. Okay, so it's a simplified. So it can be used for the indexing of the string instead of the huge size of the string data. You can have the simple hash key. So you can make such a address itself is too long. So why don't we simplify? At that time we can apply the hash function for the address. Okay, that will be one of these, right? Hash function can make the simple the value. That is a hash key. So each key will be stored at the hash bucket. Hash bucket has all the data that has the same hash key. So it's a simplified. That has this address, this address, this address. So until you can find the target. So we can simplify. Only not all these the pages. We can simplify, narrow down the search area using hash function. Then linearly search this, then find the data. Data means page number. So inverted, as we discussed, is an opposite way. So like we can manage the pages per process. Okay. So we manage because that makes sense. So CPU may use the page that related to the same process. Okay. So why don't we manage the process ID that we have the page table organized by the page ID. That is called inverted. Okay? That is the reason it's called inverted. Any questions so far? So 3 different ways. One is a hierarchical. It's like the multi-level index. The second is hash function. It's also used in the index. So it's kind of the indexing problem because we have the huge number of the pages. So how can we search to match the page number? Then that's the indexing problem. So we have learned the same algorithm in the database, and if you are taking the big data course, it's exactly the same ideas are used for indexing such a data. So these are the examples of the real operating system for the memory management. Okay, so you can read something. Then I think that we have the 2 more chapters, chapter 9 and chapter 10, right? So hopefully I'd like to finish the chapter 9 the next class and the chapter 10 the next week before Thanksgiving. Then during the Thanksgiving you will work hard to finish the project and demonstrate. So see, why don't you set up the schedule for the student before the Thanksgiving, then student will be ready for the demonstration. Okay, any question? Thank you, and see you on Thursday.